Alright, good morning guys, or good afternoon depending on when you're watching this. This is my third time starting this video, so hopefully it goes well this time. I was trying to start the video on my face and then transfer it to the document camera, but that is not working. It won't transfer in the middle of the video. So anyways, I'll do a separate video for that. So today is day 3 of triangle congruence, and we're looking at a topic called parallel lines and transversals. Parallel lines are two lines that have the same slope and they never touch or cross each other. And that's what this little symbol, this little caret on the lines means, parallel. A transversal is a line that cuts two parallel lines. It could cut 3 or 4 parallel lines, but we'll start with some basic problems. And the transversal creates all these angle relationships, and that's what we're looking at today. The first angle relationship formed by the transversal and the parallel lines is called a corresponding angle. The definition, and I would write this down since it's not on your notes, the definition of a corresponding angle is an angle that lies on the same side of the transversal in the same position. Angles that lie on the same side of the transversal in the same position. For example, angle 2 and angle 6 are both on top of each parallel line and on the right hand side of the transversal. They're both obtuse angles, so they're the same angle. Let's say angle 2 is 100 degrees, then angle 6 also has to be 100 degrees. Another example of corresponding angles would be angle 3 is going to be congruent and corresponding with angle 7. So there's 2 examples. Alright, the next type we have are called alternate interior angles. The definition of alternate interior angles are angles on the outside, these are interior, angles on the inside of the parallel lines and on opposite sides of the transversal. Alternate interior angles, they lie on the inside of the parallel lines and on opposite sides of the transversal. An example would be angle 4 and angle 6. Angle 4 and angle 6 are considered alternate interior. They are congruent. If angle 4 is 80 degrees, angle 6 is also 80 degrees. Another example would be angle 3 and angle 5. Those are also alternate interior angles. Okay, the next type we have are alternate exterior angles. The definition are 2 angles that lie outside of the parallel lines and on opposite sides of the transversal. Angle 2 and angle 8 are alternate exterior angles. Angle 1 and angle 7 are alternate exterior angles. Again, these look like they would be the same angle as well. They're both 1 and 7 are both acute. 2 and 8 are both obtuse. The next type that we have is called consecutive interior angles. These can also be called same side interior. Consecutive interior, I was looking for a highlighter. Anyways, consecutive interior can be called same side interior as well. Same side interior angles. These are supplementary. So, the 3 we just talked about are congruent, but consecutive interior or same side interior angles are supplementary. That means they add to 180 degrees. So, an example, same side interior definition is they lie on the same side of the transversal, and interior, that means inside the parallel lines. So, angle 3 and angle 6 are called consecutive interior. Angle 3 and angle 6. Angle 4 and angle 5. Alright, then we have vertical angles. Vertical angles share the same vertex, so angle 1 is congruent to angle 3. These are vertical angles. They share the same vertex here. They're diagonally across from each other. Angle let's say angle 5 and angle 7. There's tons of them. Angle 5 is congruent to angle 7. Those are vertical angles. 6 and 8 are vertical angles. 2 and 4 are vertical angles. The last type we have is called a linear pair. and they are also supplementary. A linear pair is on a straight line. That's the definition. 1 and 2. A straight line adds up to 180. They are supplementary. Angle 1 and angle 2 are a linear pair. Angle 6 and angle 7, those are still on a straight line. Angle 6 and angle 7 are a linear pair. So these are the definitions that we need to memorize. So looking at example 1, they say given that measure of angle 1 is 65 degrees, so go ahead and label measure of angle 1 is 65 degrees. Find the measures of each missing angle and give your reasoning. So your reasoning is going to be one of these vocab words that you're going to memorize. So let's just go in order. If angle 1 is 65 degrees, then angle 2 has to be 115 degrees because they're on a straight line. A straight line is 180 degrees. So 180 minus 65 is 115. These are called a linear pair with each other. Measure of angle 2, let's say linear pair with angle 1. Alright, angle 3. I'm going to go back to angle 1 and say that angle 1 and angle 3 are congruent because they are vertical angles. So measure of angle 3 is 65 degrees because it is a vertical angle with angle 1. Alright, number 4. Number 4 is going to be 115 degrees, and that's going to be a vertical angle with angle 2. Now your reasoning could be different. You might have put that angle 4 is 115 because it's a linear pair with angle 3. And then you would have said 180 minus 65 gives me 115. These are linear pairs. These two, angle 2 and angle 4, are vertical angles. Alright, measure of angle 5. I'm going to say measure of angle 5 is 65. I'm going to use the reasoning just because we haven't used this one. That measure of angle 5 is going to be an alternate interior angle with measure of angle 3. They're inside the parallel lines and on opposite sides of the transversal. And that is with angle 3. Alright, angle 6. Angle 6 is going to be 115 degrees. And that is, we can say, let's use a new vocab word. It's corresponding with angle 2. Corresponding with angle 2. Alright, measure of angle 7. I'm going to use alternate exterior angles. They're on opposite sides. 1 and 7 are alternate exterior angles. So measure of angle 7 is 65 degrees. My reasoning, alternate exterior with angle 1. Okay, I did skip one of the vocab words, but that's okay. Plenty of more problems to do. Measure of angle 8. Let's say we've done linear pair, vertical, alternate interior. I think the only one we haven't used would be the consecutive interior or the same side interior. Everything else we've used, so measure of angle 8, that's not going to be consecutive interior because it's on the outside. Let's just say it's going to be vertical angles with angle 6. Again, there are multiple correct answers for these problems. Alright, flip to the back. We are going to go to example 4. It's slightly different. And you always want to start by filling in the information that they give you. Now this one looks a little funky because we have our 2 parallel lines here because of these markings. And then we have 2 transversals. So just looks weird. Let's go ahead and label what we're given. Measure of angle 12 is 121 degrees. And then measure of angle 6 is 75 degrees. So always label what you're given first. Alright, let's go from here. Measure of angle 1 is going to be 75 degrees because, and I'm not going to try to label it all here, It's just going to get messy, but 1 and 6 share the same vertex. They're vertical angles. Imagine if this line was gone, these would be vertical angles. All right, let's look at measure of angle 2. Can we get measure of angle 2? Not quite yet. We might have to do some jumping around here. I can look and see that measure of angle 8. If I have that this is 121, then measure of angle 8 has to be 180 minus 121, which is going to give me 59 degrees. These are called a linear pair. Which then I can say 7 and 12, angle 7 and angle 12 are vertical angles. They're congruent. So angle 7 is 121 degrees. And then 7 and 11 lie on a straight line, linear pair, adds up to 180. These are supplementary. So if 7's 121, then measure of angle 11 is going to be 59 degrees. Okay, so that got us this whole grouping here. We did 7, 8, 11, and they gave us 12. Okay, so let's look at measure of angle 3. Measure of angle 3 is going to be 59 degrees because we said measure of angle 8 is 59 degrees, and these lie in the same position. Again, if you ignored this line here, these are called corresponding angles. So that's how I know measure of angle 3 is 59 degrees. Now that's going to help me find measure of angle 5 because I have measure of angle 3 is 59 degrees, measure of angle 6, this angle here, 75 degrees, and all three angles are on a straight line. A straight line is 180 degrees. So if I add 59 plus 75, subtract from 180 to get angle 5, that's going to be 46 degrees. Again, I found out that measure of angle 3 is 59 degrees because measure of angle 8 is 59 degrees. They lie in the same position. They're corresponding. And then I found 5 because all three angles have to add up to 180. So I added these two and subtracted from 180 to get 46 degrees. Which is going to help me find measure of angle 2 because 2 and 5 are vertical angles. They share the same vertex. So it's like a big puzzle. I love these problems. Angle 4 is 59 degrees because they're also vertical angles. So go ahead and fill that one in. Ooh, measure of angle 9. Measure of angle 9. That one, I guess there's a couple different ways to look at it. I think probably the easiest way is that 6 and 9 are alternate interior. Let's use that one. 6 and 9 are alternate interior. And if you look back at our definitions, alternate interior angles are congruent. So that's why measure of angle 9 is also 75. Almost done. I mean, it's just memorizing the definitions, and really there's only two angles that add up to 180. The linear pair, which is the straight line, and then the consecutive interior. Let's see if we can use consecutive interior. No, we can't on 13 and 14. 13 is going to be the same as 10. Oh, we don't have 10 yet. Okay, well, if we have 9, if 9 is 75, we take 180. 9 is 75 degrees. We already had that over here. I forget. Oh, we found that with the alternate interior. But anyways, I can find angle 10 because it's on a straight line. So 180 minus 75 is 105. That's called a linear pair. And then if 10 is 105, 13 has to be 105 because they're vertical angles. 9 is a vertical angle with angle 14. So angle 14 is 75 degrees. And we're done. Okay, it looks different with these. If we go up here, back to example